Hello, our task was all about the optical laser plummets, verification and testing. We wanted to know which one was best. Our group consisted of Andrew, Carton, Daniel and John. Unfortunately, none of us could turn up today. Plummets have been used since the early times of surveying. They're used to tie the location of surveying equipment to the ground. They were used by the ancient Babylonians and Egyptians, and stone plumb bobs similar to the one shown are found dating from these times. The optical plummet first started around 1950s, and around 1980s the laser plummet was introduced. The aims of our task was to determine the precision and accuracy of the laser and optical plummets. We assessed the performance and looked for sources of errors. We decided to use the laser plummet of the TSO6 and the optical plummet of a Leica Tribac. Possible research methods. We found one method was to use the bench method, which is basically a total station laid on a bench and an optical Tribac attached to the total station. There's also a calibration drum method, whereby a calibration drum is put on a Tribac. And for the laser, we decided to place the laser some distance from the floor so that the errors would be exaggerated. The specifications for an optical Tribac are 0.5 millimeters deviation at 1.5 meters height, and for the laser it's a 1.5 millimeter deviation at 1.5 meters height. They're both specified at 2 sigma. This, for example, on the optical sight means that when you're targeting using the sight, you'll be able to position your sight within 0.5 millimeters of the target 95% of the time. This is in laboratory conditions. Sources of plummet error. Sources of plummet error include plummet misalignment. This includes the surveyor not aligning the plummet with the target correctly, or it could be the plummet in the instrument is not aligned correctly. Another source of error is plate level error. This means that the Tribac or instrument isn't leveled correctly, even despite the fact that the bubble shows it is. A centering error is that the center of a Tribac is not precisely put in the center. You can get errors with the tripod being knocked, and there's human errors that can be involved. Another source of error can be atmosphere. Sometimes you get refraction due to heat differences. In our case, we assumed that refraction due to heat would be very low because the heat was fairly constant. I'll now hand you over to Daniel, who's going to tell you about the laser plummet and the method we used to test it. Laser plummet has advantages and disadvantages. An advantage is that it's easier to use and set up. Disadvantages include the accuracy depends on the observer's judgment of setting the beam, being able to judge the center of the beam whilst placing it over a target. A laser can be hard to see in bright light, and it can be less precise. In this task, we set the total station above the top of the stairs. We measure the distance from the base of the total station to the floor, and we set a target on the floor. This is the target we put on the floor. We switched the laser on, and it was as shown, like an oval shape. We traced around the laser beam and also marked the center. We slowly rotated the laser in the total station around 360 degrees and marked it at regular intervals. We then, on the computer, we put a circle over the dots, which this circle is an ellipse error, and the center of the ellipse represents the average error. We repeated this. We actually repeated it with the target upside down, and the two results are shown. From this, we were able to read off the mean errors and mean beam widths. The sources of error in this task were in judging the center of the beam and the possible slipping of the tripod on the floor. as it was a very slippery floor. The qualitative method we considered to be good because the errors were very easy to read off, and also any human errors were easy to check simply by rotating the total station around a second time and making sure it came back at the same point. I'll now hand you over to Carlton, who's going to tell you about the optical plummet and the methods we used to try and verify and test it. The optical plummet has advantages of being precise, easy to use in good lighting, and easy to target. It's also easy to calibrate and cheap to replace. A disadvantage is that it can be a little bit trickier to set up than that laser plummet. Also, it can be unsuitable for dark targets and in poor lighting. We used the bench method first to test this optical tryback. We secured the instrument on the desk and placed a target on the wall. We rotated the tryback through 90 and 180 degrees, and another person marked the points on the target corresponding to what we saw through the sight. Possible sources of error in this method were that the target was hard to see, and also other human error. Also, the instrument had to be secured to the desk, and in case it got knocked. We decided the quality of this method was quite poor due to the poor visibility of the target. Another method we used to try and test the optical plummet was the drum method. The drum method is as follows. A tryback is set up and leveled on a tripod, and the drum is placed on top of that tryback. Another tryback is placed on top of the drum upside down. This enables you to see the ceiling through the optical plummet. A target was placed on the ceiling together with a ruler. This enabled us the position of the target is recorded by photographing it through the lens of the optical tryback. The tryback was rotated through 180 degrees and the position was recorded again. In the picture you can see the two photographs we took overlaid, and the error could now be read straight off the ruler. Sources of error in this method were in the clarity of reading the ruler. The quality we considered was very good. The triangle bracket was used for the tripod, which reduced any slipping. The levels were double checked with a total station, and also there was a target on the floor that we could use to check the centering of the tryback throughout the process. The results are shown, and Daniel will just quickly talk you through the results. Results show that laser 1 and laser 2 performed within specification. For laser 1 we had a scaled mean error of 1.2 mm, and for laser 2 1.7 mm. On average, this gives us a scaled mean error of 1.5 mm, which was as specified. The beam width on average was around between 3 and 3.5 mm, which is around 1 mm larger than specification. However, we expect the beam to be slightly larger than specification because we were using it over a larger distance. The results for the optical show scaled mean error of around 1.6 to 1.7 mm. In the specification, it was only 0.5 mm. This showed that the results were worse than specification, and this was probably due to the tryback not being calibrated. And John, would you like to tell us about the analysis? The optical was not accurate as it was not calibrated. I believe that the optical would have been more precise than the laser if it had been calibrated. The laser was accurate but less precise than the calibrated optical. I believe precision is dependent on the observer judging the center of the beam, and the laser quality could be checked easily, however. In conclusion, which is better? Laser Plummet is better, of course, for everyday tasks. It's quick and easy to set up, and the accuracy can easily be checked simply by rotating the instrument through 180 degrees and seeing if the laser beam moves more than 1.5 millimeters. The optical plummet, of course, is better for precise work, as can be seen from the specifications. So overall, I'd say laser was better. These are the references we used. Have you got any questions?